Hey, welcome back. So at this point we have our apple tree, and if we play or simulate, it's going to move in one direction. It's going to keep moving in that direction. Actually, I'll just go and pin that details tab there. You can see it's going to keep moving. All right. So what we want to do in this video is we want to set up some sort of a boundary so that if I move this in the positive right vector, at some point it's going to reach a boundary, and then it's going to change direction and move into the opposite direction until it reaches the negative of that, let's say minus 1500 or something like that in y, and then it's going to change direction again and move back. And eventually we want to spawn apples from this tree, and at the bottom we'll have a pedal that we can move to the left and to the right with keyboard input, and then we want to catch those apples, right? Go to tools and I'll open up Visual Studio, and actually I'll just close off this here. I'm not going to save anything. For this we need some sort of a value that maybe the artist can change later on. So in the treebase header, treebase.h header, I will go and define another float. We can set up a barrier or a boundary in different ways, but at least for this project, I want to show you how we can do this programmatically. The tree actor is not allowed to move beyond this boundary. If the tree reaches that boundary, it's basically going to move in the opposite direction. So as it moves to the right, it's going to change direction, and then it's going to move to the left. That is on the y-axis. In the constructor, we'll set up a default value for that. We initialize our movement speed and our boundary. And I'll go back here to the tick function, just save all here. For an exercise, get the actor to move in the opposite direction when it reaches the boundary that we have set up. That is going to be in the tick function. And as a hint, you can use the ABS function of the fmath library to get the absolute value of a variable. Let's move on and implement this. I'll just go and add spaces in here to make it a bit more consistent with the existing comments. Alright, what we want to do is, firstly, every tick we want to get the actor's current location, but then we want to do a check. Firstly, we want to check if the apple tree is within the bounds. How do we do that? We use that location, we get y from that, and then we check if it is less than or equal to the negative of whatever the boundary is. Remember that the boundary, if we scroll up, is defined to 850. So if it is negative 850, the apple tree has moved to the left. Then we want to move to the right. You may have to think for a second, how do we do this? Remember, we have this movement speed, and that is defined as well and initialized to 550. That is a positive value. So what we can do is we can modify that movement speed, and of course down here we are going to then multiply, let's say, a positive or a negative value with the delta time, which we then apply to the temp location. Typically, as we had it set up at the moment, it's going to start off by moving to the right. So in this check, as I have it right now, we are checking for the left boundary. So in other words, the movement speed is going to be modified at that point to be negative. So we want to set it back to a positive value. If you think back to the basics of C++, how do we get the value of the positive value of some variable, whether it is positive or negative? You get that positive value back. Well, that is called the absolute value. We only want the positive or the absolute value. We don't want the negative value. So in that case, we can use the absolute function. In Unreal Engine, we have the fmath. As you can see, I have a templated version of this here, double float and so on. So the fmath here is a structure containing math helper functions with platform-specific implementations. If you want to do mathematics in Unreal Engine, use the fmath functions instead of the standard library functions. Again, what we are doing here is we are passing in movement speed. If movement speed is negative, which it will be when the tree actor is on the left side, then we want to change that back to a positive value using the ABS function. Okay, and of course, in the L section. We are now in the positive section, so in the positive right vector. So in other words, if we are not in the negative right vector, then we are in the positive right vector. So temp location.y is greater than or equal to the boundary. We want to do a check for that. Then we want to move left. Just to be sure, I'll actually do the same thing that we do up here. I will get the absolute value of the movement speed, and then I will set that to the negative of that and assign that to the movement speed. We know that when we reach the right side of the boundary, that is in the positive right vector, that we will now go and change direction basically and move left. Okay, and we do that by setting the movement speed to the negative of whatever the absolute value of the movement speed is. And then we go and add an offset. We go and do this calculation, and then we set the actor location. So again, we go ahead and we get the actor's current location in that particular tick. We check the location. So where is the tree located currently in the world? We are concerned with the y axis. If that is less than the negative of the boundary or equal to that, then we want to move right. Otherwise, if we have reached the right side of the boundary, then we want to also go ahead and change direction and move left instead, okay? Then we go and apply that offset. Finally, we set the actor's location to the temp location that we calculate right here. Okay, so with that, I will go ahead and build and run. And the editor will load up here. And if I simulate or play now, let's see what we get. And you can see that it will change direction. Each time it reaches the negative or the positive boundary, it's going to change direction and move in the opposite way. Alright, and that's what we wanted. So that is going to wrap up this section. In the next lecture, we'll continue on. We will make this movement a bit more erratic so that it will randomly change direction every second or so.